Hello, everybody, and welcome to this week's lesson. This week we are on part 3 of our functions topic that we're working on. We're in Unit 9, Evaluate and Compare Functions. So this unit really builds directly on top of our last 2 weeks of lessons. I would highly recommend that you work through those lessons first before you tackle this one. I would also highly recommend that you have your lesson notes from the last couple of weeks next to you as we work today. You'll also need your welcome packet, something to write on and something to write with, and you might find a calculator to be useful. All right, so we're going to get started with this warm-up question on the screen here. This is a question taken directly from last week's lesson. It says, what is the slope of the line that passes through the points -2, 4, and 3, 2? So I would recommend that you pause the video right now, give this problem a try. If you can't remember what to do here, see if you can find this information in your lesson notes from the previous weeks, and then return to the video when you're ready to go through it together. All right, so what is the slope of the line that passes through the points -2, 4, and 3, 2? So first thing, if we're gonna figure out the slope, we need to remember what is slope. What does slope mean? Well, slope is the rate of change of a linear function. And it's a rate of change where we're comparing the change that's happening with our y values or our outputs compared to the change that's happening with our x values or our inputs. So change in y compared to change in x. So how do we determine slope if we are given 2 points? Well, we want to remember that 2 points are all we need to define a line, right? If I put 2 points somewhere on this screen, I can connect those 2 points with a straight line. That line will be in a different location. It'll be a different line from this line here that I'm drawing between another 2 points. So 2 points are all you need to define a line. So we've been given 2 points to describe a line to us. We want to determine the slope. So we need to determine the change in y over the change in x. And the way that we do that here is we can subtract. So when we're given coordinate pairs like this, we want to remember we get our x value first, y value second, x and y. So our slope, which remember we sometimes abbreviate with the letter m, will be equal to the difference in our y values compared to the difference in our x values. Now those little numbers there, the y2, y1, x2, x1, those are just labels to indicate that we've got 2 different values that we're subtracting. So I'm going to go ahead and subtract. I'm going to subtract my y values, 4 minus 2. And I'm going to subtract my x values, -2 minus 3. 4 minus 2 is 2. -2 minus 3 is -5. So 2 over -5. We cannot simplify this fraction any further. We could, if we wanted to, rewrite it as a decimal, but that's not necessary. The question doesn't ask us to do that. Since there is a negative sign here, usually what we will do in our final answer is we will pull it out to the front and write it like this. So the slope of this line is -2 over 5, or -2/5. That means for this particular line, each time we go down 2, we go over 5. Down 2, over 5. Down 2, over 5. That describes the slope of this line. All right, so what are our learning goals for this week? By the end of this week, you will be able to use algebra-related vocabulary to discuss and explain problem solving. So that's the same goal we've had for the last couple weeks. I really want you to be focusing on vocabulary and using vocabulary when you are thinking about these problems to yourself, when you are writing things down, when you're talking to me. We're going to evaluate linear and quadratic functions for values in their domain when represented using function notation. And we're going to compare properties of two linear or quadratic equations, each represented in a different way. All right, and at the beginning here, I just have a little review. I'm actually going to skip over this right now. We did this during our Zoom lessons, but if you want to review these ideas, you should just go back and watch the lesson videos from last week and the week before. So Unit 7 on functions and Unit 8 on linear functions. And so we're going to get right into our new ideas for today. So first thing I want to talk about are quadratic functions. Last week we focused on linear functions. And so now we are also going to be working with quadratic functions. Quadratic functions are just one type of function or equation you might encounter. It's where your input variable has an exponent of 2. So I've got a couple of examples on the screen here. The simplest quadratic function that we could have is y equals x squared, or y equals x to the power of 2, right here. And then you can get more complicated than that. I've got this function here, y equals -1/2 x squared plus 3x minus 1. Notice that in both of these, no matter if they're quite simple or quite complex, the highest exponent that we see on the x is x squared. So it's that exponent of 2 that makes it a quadratic function or a quadratic equation. When you graph quadratic functions, they're always a curve, and they're always this one special type of curve called a parabola. You don't have to remember that word, it's not super important, but you might hear it thrown around if you're watching some videos or reading books on this topic. And parabolas look like this graph here. It's this sort of shape that's like in between a U and a V. So that's what a parabola is. Sometimes they can be wider or thinner. Sometimes they can be upside down. So you could have a parabola that's like flipped over. But anytime you've got an x squared, you're going to get this general kind of curve in your graph. Okay, so now that we know what quadratic functions are, we're going to talk about evaluating functions. So evaluate, whenever you're asked to evaluate something in math, it means they're asking you to find the value. So basically they want you to do a calculation and get an answer. So typically, if you have a problem where you're being asked to evaluate a function, what's going to happen is you're going to be given a number for x. So you're going to be told an input value, and you need to calculate the value for y, for the output. So they tell you the input, and then you do your little calculations, and you get the output. You can sometimes get it the other way around, where you're told the output and you need to figure out the input. We're going to worry more about those types of questions next week. So this goes back to that second learning goal that was listed at the beginning of our slideshow, where it says evaluate linear and quadratic functions for values in their domain when represented using function notation. Sounds very long and complicated. But again, it's really just saying we're going to evaluate these types of functions for input values when represented using equations. So when we say domain, that refers to all of the input values of a function. It's just another name for input values. And when we talk about function notation, we're really just talking about equations. So a function that's written as an equation instead of as a graph or a table or a verbal description. And sometimes when we have things written in function notation, you will see that we're using f of x instead of y for our output. Means the same thing. So let's try this example down here. It says evaluate f of x equals 4x for x equals 2. So this problem is telling me that my input is 2. So I'm going to plug in. my input. So I'm going to replace x with 2. I'm going to put parentheses around that 2. That's a good habit to get into whenever you are replacing a variable with an actual number, is to put parentheses around it. It will help you keep track of positives and negatives. It'll also just help you keep track of like what are the changes that you've made to this equation. It makes it a lot easier. So I'm going to plug in that 2, and then I'm going to chug through this calculation. So plug in the number and chug through the calculation. 4 times 2 is what it is telling me here. Oops. 4 times 2, which is 8. So for this particular function, when our input is 2, our output is 8. So we could write that as a little coordinate pair. We could say 2, 8 is an input-output pair for this particular function. So our answer is 8. And that's all there is to it. Evaluating functions is really just a matter of working carefully through the calculations. We're also going to take a look at a few different practice problems here that phrase the questions in slightly different ways. I think that can be one of the more challenging things about this type of problem. Not that it's asking you to do anything too crazy, but just that the wording can be really different from one problem to the next. So let's try some of these out. Number 1. Given the following equation, fill in the chart for all values of f of x. And so we have this equation, f of x equals 2x squared plus 1. And then we have this table or chart where it gives me a bunch of x values. And then we are supposed to calculate the corresponding outputs or the corresponding f of x values. So to do that, we're just going to go one by one through these values, plug in the input, and calculate the output. So let's start with the first x value. We're going to have 2x squared plus 1, so 2 negative 1 squared plus 1. Now, with this calculation, I have more than one operation here. I see multiplication, I see an exponent, and I see addition. So when we're working through a calculation with multiple steps here, we want to make sure that we are following our order of operations. And in your welcome packet, the last page of your welcome packet is a handout with the order of operations written on it. So if you've got your welcome packet handy, you can take that out now. So on the last page, you'll see that it goes through the order of operations. The order of operations is, it's an order that we all agree to follow. It's also an order that like calculators and computers follow when they are working through multi-step calculations. And so we always do work within parentheses first. So parentheses are first. The second thing we work on are any exponents or roots that we see. The third thing we work on is multiplication and division. And if you have, let's say you've got multiplication and division within the same problem, you would work those left to right. So within each of these levels, if you've got multiple instances of the same operation, you work left to right. And then our final level here, the fourth level of operations, is addition and subtraction. So for this calculation, I've got multiplication, an exponent, and addition. I do technically have parentheses, but those, if you look inside the parentheses, there's not actually any work to be done inside of them. They're just holding a number. So we can ignore the parentheses and just move on to dealing with those exponents. So the exponent is attached to the number in the parentheses. It's attached to the -1. So first thing I'm going to do is -1 squared, which means -1 times -1. -1 times -1 is 1, right? Negative times a negative gives you a positive. So we get 2 times 1 plus 1. All right, now I've got multiplication and addition left. So I'm going to do that multiplication first. 2 times 1, which is 2, plus 1. 2 plus 1 is 3. So for this function, when I input -1, I get an output of 3. Okay, so let's try the next one here. So I'm going to plug in my next input, which is 0. 0 squared is 0. 2 times 0 is 0. 0 plus 1 is 1. So an input of 0 gives me an output of 1. Okay, and I would highly recommend that you pause the video right now and see if you can complete this table on your own, and then come back to the video to check your answers. The screen just went blank. I did not mean to do that. Okay, so f of x equals 2 times 1 squared plus 1. 1 squared first, which is 1. 2 times 1 is 2. 2 plus 1 is 3. So we get the same output here as we did with -1. And now we're going to do the same thing with 2. Sorry, guys, I'm working on a different computer from where I usually record, and my the buttons on the little tablet that I'm using are giving me some trouble. So while I mess around with my buttons here, you can keep thinking about these calculations. Okay, so we're going to have an input of 2 next. 2 times 2 squared plus 1. 2 squared means 2 times 2, which is 4. 2 times 4 is 8. 8 plus 1 is 9. So we get an output of 9. All right, and on to our final one here. Input of 3. So 2 times 3 squared plus 1. 3 squared is 9. 2 times 9 is 18, plus 1 is 19. So an input of 3 gives us an output of 19. And so we have just evaluated this function for the input values -1, 0, 1, 2, and 3. All right, on to number 2. For input k, the function f is defined as f of k equals -2k plus 1. What is the value of f of -8? So this is the same type of question where they are asking you to evaluate this function for a given input value, but it's asked in a pretty different way. And I think if you were maybe taking the test and reading this question for the first time, it would look a little bit scary. It might look a little bit scary, but it's really just telling you a function. Here, instead of using x as our input variable, we're using k as our output variable. We're using k as our input variable. So we have f of k equals -2k plus 1. And then we want to evaluate this for an input of -8. So f of -8 means that we should input -8. So I'm going to do that. -2 times -8 plus 1, following my order of operations. So I'm going to do that multiplication first. -2 times -8 is 16, plus 1 is 17. So 17 is our output when we input -8. All right, number 3, choose the coordinate pair that is a solution to the function f of x equals 2x squared. So looking down these answer choices here, we've got these coordinate pairs. So you want to remember that a coordinate pair is just an input-output pair, right? It's a pair of x and y that goes together for a function. So we want to find an xy pair or an f of x pair that works for this particular function. So we're just going to go through the answer choices and start testing them out. For A, I've got an input value of -2 and an output of 8. So I'm going to input -2 into my function, and I'm going to see, do I get 8 as an answer? So remembering your order of operations, right, we should do -2 squared first. So it becomes 2 times 4, which is 8. So this coordinate pair works for this function. When I input -2 into this function, I do get an output of 8. And so A is the correct choice. Now, if we want to, we can test out the other ones. We can see that these ones won't work. So I'll show you. If we do 2 times -3 squared, that's going to become 2 times 9, which is 18. We did not get -18, right? So when you put -3 into this function, you get an output of 18, not -18. So choice B will not work. And let's do the same thing with choice C. 2 times 4 squared. 4 squared is 16, so that's 2 times 16, which is 32. So for this particular function, when you input 4, you get an output of 32. So choice C is not going to work. All right, so what I want to do next is I want to go through a few function-related word problems just to give you more exposure to the different types of function problems you might see. So all of these are related to things we've already talked about in terms of representing functions in different ways, talking about slope, talking about y-intercept, all of that stuff. So number 1. Coast to Coast Wireless offers a family phone plan. The plan is $25 a month for 2 lines plus $10 per each additional line. Which of the following equations represents the monthly cost of the family phone plan based on the number of additional lines? So, you should pause the video, take a look at the answer choices, and pick which one you think best represents the monthly cost of a family phone plan based on the number of additional lines. Okay, so the correct answer here is choice C. Let's think about what choice C is telling us. It says y equals 10x plus 25. So this is supposed to represent the monthly cost of the plan based on the number of additional lines. So I can guess that y is the monthly cost. So our monthly cost is equal to 10. So $10 per each additional line. So $10 per each line times the number of additional lines plus $25. And this matches the information we're given in the problem, right? The plan is $25 a month for 2 lines. So that's kind of the initial fee. That's like the baseline. So if we're on the family plan, we're definitely going to be paying $25 a month. And then we have to add $10 for each additional line. So if you had 1 more line, you would pay $35 altogether. If you had 2 more lines, you would pay $45 altogether. 3 more lines, you would pay $55 altogether, and so on, right? So this part of the equation here, the 10x, or the $10 times the number of lines, that is the part that is varying or changing based on the number of additional lines we have. So this equation says our monthly cost is going to be $10 times the number of additional lines plus that $25 baseline fee. All right, number 2. The graph shows Billy's savings for last year. How much money did Billy have in her savings at the start of the year? And this is a little bit covered up by my footer at the bottom here. But the very bottom of this graph, the bottom line, that is the x-axis. So right here is 0 on the x-axis and 0 on the y-axis. And then we have our first month, which would be January, our second month, our third month, our fourth month, fifth month, which would be May, and so on. Okay. And then going up along the y-axis, we see that the y-axis represents her savings. So this is Billy's 2019 savings. Question is, how much money did Billy have in her savings at the start of the year? So before the year happened, right? Let's say New Year's Eve, you wake up on January 1st. How much money did she have in her savings account? Well, that's going to be before we get to the end of January, right? That's like at the beginning of January. So that's going to be right here. Right at the very beginning of the year, when we're just getting started, she's going to have $10 in her savings. We could also notice that another way we could say this is that the y-intercept of this line is 10, right? This line crosses the y-axis at $10. All right, how much money did Billy put in her savings account each month? So she started with $10, and then at the end of January, she had $15. At the end of February, she had $20, and then March, she had $25. April, she had $30, $35, $40, $45, $50. So to me, it looks like each month she is going up by $5. Right? Each month she's increasing her savings by $5. So she is putting $5 into her account each month. She starts with 10 and then she adds on 5 each month. All right, so now we want to choose the equation that represents Billy's savings, Y, based on the month, X. So take a look at these equations, take a look at your answer choices, and think about what we talked about last week with linear functions. Also think about how you would calculate her total savings for any particular month. All right, so the correct answer choice here is D. She starts with $10 and then she adds $5 times the number of months it's been, right? So $5 is the amount that you're going up each month. $10 is actually the y-intercept. It's where the line crosses the y-axis, and 5 is the slope. Last week we talked about equations that are in this form where you have y equals the slope times x plus or minus the y-intercept. We talked about equations that are in this form. This is a super common type of equation that you're definitely going to see show up on the test. And that's how this equation relates to this situation, right? So she starts with $10 in her account, and then each month, right? So after 1 month, she's at 15. So if we were to do 5 times 1 month plus 10, we would get $15. After 2 months, by the end of February, she's at $20, right? 5 times 2 plus 10 will give us $20. March, she's at 25, right? 5 times 3 plus 10 would give us $25. So choice D corresponds to the information that we see on this graph here. All right, so what we are going to do with the rest of our time today is we are going to look at problems where we're asked to compare functions. Now, none of these problems is talking about really anything new. We're just going to be comparing properties of functions that we've already worked on. So you're going to be looking at two different functions and you're going to be comparing their slopes, their inputs and outputs, their intercepts, and you might also be asked about minimums and maximums. So let's talk about those words for a minute. Minimums and maximums. What are minimums and maximums? Have you heard those words before, or min and max? So minimum is the lowest value. That's what minimum means the lowest value. And maximum means the highest value. So if you were looking at a curve like this, the minimum would be right here at the bottom. That would be the lowest point on the graph. If you were looking at a curve like this, this highest point right here would be the maximum. So nothing too crazy, right? You would just be looking at a graph and looking at what's the highest point or what's the lowest point. Okay, so let's take a look at some problems where we're comparing functions. A function has a rate of change greater than the graph shown below and less than the table shown below. What could be the equation of the function? Okay, so in this situation, we have a mystery function. And all we know about it is its rate of change, or its slope, is greater than the slope we see on the graph, and it's less than the slope we see in the table. And we're gonna use that information to help us invent an equation for this function. So what's the first thing we should do? Well, we need to figure out what's the slope of the graph and what's the slope of the table. So for the graph, I'm going to do what we always do when we're finding slope on a graph. I'm going to pick a point, pick another point, and I'm going to see how far do I need to go up and how far do I need to go over to get to the second point. So the slope of this graph, I had to go up 2 over 3. So the slope is 2 to 3, or 2/3. And you can see that that works all the way along this line. We can keep going up 2 over 3 all along the line. All right, and then what about the table? So we're going to look at the change in outputs. -3 to -1 is an increase of 2 versus our change in inputs. -2 to -1 is an increase of 1. And we can see that that is true all throughout this table. So each time in my outputs, I'm going up by 2, and in my inputs, I'm going up by 1. And so this linear function has a slope of 2 to 1, which we can simplify to 2. So our mystery function, we don't really know too much about. We know that the slope of this mystery function is in between 2/3 and 2. So it's greater than 2/3 and it's less than 2. So what is a number that's more than 2/3 and less than 2? Well, there's infinitely many numbers that fit that description, but let's keep it simple. Let's choose 1, right? 1 is more than 2/3, but it's less than 2. So I'm going to choose a slope of 1. And now we just need to come up with an equation. We need to come up with an equation that has a slope of 1. So remember, the linear equations we've been working on have had this form of y equals the slope times x plus or minus the y-intercept. So for our mystery function, I'm going to use a slope of 1, so 1x, and then I can pick any y-intercept I want, right? Because we just want to know what could be the equation of this function. As long as it matches the information we've been given, the rest of the stuff we can just pick what we want. So I'm going to do a slope of 1x plus 4. That's it. So this is an equation that has a slope that's greater than the slope on the graph and less than the slope on the table. Now when you have a slope of 1, notice this is saying 1 times x, or 1x. 1 times x is just going to be x, right? 1 times any number is just itself. So oftentimes when you're talking about a slope of 1, you would actually just see that written like this. You would see it written as x. It means the same thing. We just don't usually include that 1 because it's kind of implied, even if we don't write it. All right, what are some other equations I could pick? Well, what's another number between 2/3 and 2? 3/4. 3/4 is bigger than 2/3. So 3/4 x minus 5. That would work. We could do 1.9. Right, that's still less than 2. 1.9x minus 2/5. That would be fine too, right? So you can literally, since this is not multiple choice, right, it's asking you to come up with an equation. There are infinitely many correct answers to this. As long as your slope is in between 2/3 and 2, you're good to go. All right, let's try our next one here. So 2 moving truck rental companies are shown on the graph. Bluegrass Haulers is shown in red, and We Move is shown in blue. Which company would be cheaper if you only plan to drive 3 miles? So take a minute to look at the graph. Again, you want to notice that the very bottom edge of the graph here is the x-axis, so that represents so the bottom there is 0. The corner right here where both of the axes start represents 0 for both of them. Okay, so which company would be cheaper if you're only planning to drive 3 miles? Well, when I go to 3 miles on my graph, I come up here. All right, I see that the blue line is under the red line. So the blue line, right, at 3 miles, I can see it's somewhere between $25 and $30. Let's say it's like $27. And the red line is more than that. The red line is a little bit above 35. So the blue line shows a lower cost for 3 miles. And so we would say that We Move is cheaper. All right, number 2, how much does Bluegrass Haulers charge per mile? So Bluegrass Haulers is shown in red. How would we figure out how much they charge per mile? Well, you might be tempted to kind of estimate. So you might start at 0 and kind of go up to where it is at 1. And you might try to sort of estimate this way. I think this would be a harder way to do it because it's not totally clear how much you're going up each time. Like it could be $2 that you're going up, but maybe it's $2.50 or maybe it's like $2.15. It's a little bit tricky because we're like in between labeled numbers here. So what I would recommend doing is instead of choosing points that are like floating in between labeled numbers, I would choose points that are sitting on lines, that are sitting on labeled numbers. So I'm going to start with this point here. And then I'm also going to choose this point right here. So to get from my first point to my second point, I would need to go up to 40. So I had to go up 10, right? Going from 30 to 40 is up 10. And then over 1, 2, 3, 4, 5. Over 5. So I just went up 10 and over 5. 10 over 5, that simplifies to 2. So that tells me that if you thought it looked like you were going up by about $2 each mile, you were right? So each time we go up a mile, the price is increasing by $2. So $2 per mile. So the slope of that red line is $2 per mile. The rate of change, right, the amount it's going up each time is $2. All right, number 3, what is the meaning of the y-intercept of the blue line? So we're talking about the blue line here. Remember, y-intercept means where the line crosses or touches the y-axis. So the y-axis, right, is over on the side here is the vertical axis. So here is the y-intercept. The y-intercept is at 10. It's at $10. So what does a y-intercept of $10 mean for this blue line? Well, that $10 is what you have to pay before you've driven any distance, right? That's when you're at 0 miles. So $10 is like the initial fee or like the baseline fee for this rental truck company. So we could say that it's like the initial fee for WeMove. So before you start driving anywhere, right, just to rent the truck itself, you have to pay $10. All right, and then number 4, what mileage costs the same for both companies? So we look and we see that at this point right here is where the 2 lines are the same, right? That's where they have this point in common. That's at $40 and 5 miles. So driving 5 miles costs $40 for both of these companies. So a mileage of 5 costs the same for both companies. All right, so we're going to do a few more practice problems before we wrap it up for today. Number 1, which statement is true about the 2 functions shown below or to the right? All right, so I look at my functions, I see it's 2 graphs, so I'm shown 2 graphs. One of these functions is called f of x and the other one is called g of x. I look at them and I actually see they're both quadratic functions. They both have that special curve. You don't really need to know that here, but you might want to notice that they're not linear, right? They're curved functions. All right, so I'm going to go through and I'm going to read my answer choices. When I look at the answer choices, it looks to me like all of them are talking about either minimum values or x-intercepts. So when I'm looking at these 2 graphs, I want to be paying attention to minimum values and x-intercepts to see which of these statements is true. So statement A, it says f of x and g of x have the same minimum value. Well, let's check out their minimum values. So f of x has a minimum value of -1. G of x has a minimum value of 1. Are those the same? No, they're not the same. So f of x and g of x do not have the same minimum value. I'm going to mark off that answer choice. That's not going to be it. All right, choice B, f of x and g of x have the same x-intercepts. Now, so far we've really only focused on y-intercepts, but if you know that a y-intercept is where the function crosses the y-axis, then you can probably guess what an x-intercept is, right? So an x-intercept is where the function crosses the x-axis. So let's compare them for these two functions. F of x, I see that it's crossing the x-axis here, so like between -1 and -2, and it's crossing the x-axis here between +1 and +2. Let's go over to g of x, and I see g of x isn't touching the x-axis at all. It's not touching the x-axis at all, so it has no x-intercepts. So they can't have the same ones, right? If f of x has 2 and g of x has none, it's definitely not the same. So I'm going to mark off B. That can't be the answer. Choice C, g of x has a higher minimum value. Well, we looked at the minimum values already. F of x has a minimum of -1. G of x has a minimum of 1. 1 is higher than -1, right? A minimum value of 1 is higher than a minimum value of -1. So I think choice C is what we're looking for here. Choice C is the true statement. All right, number 2. The equations below show the total earnings for 2 employees based on commission. The variable X represents the amount of money the employee has made in sales. The variable Y shows the employee's earnings. If each employee makes $500 worth of sales, who will earn more money? So these are equations that show earnings based on commission. When you work on commission, it's usually a percent of your sales that you earn. So equation A is showing a 20% commission, right? If you think back to our unit on percents, we talked about how decimals and percents are related. Employee B is making a 30% commission. So maybe they've worked at the company a little bit longer, they get that higher commission. So who will earn more money? Well, we actually don't even really need to worry about that $500. If they both make $500 worth of sales and employee B gets 30% of that and employee A gets 20% of that, employee B is definitely going to earn more, right? It's a higher percent of it. So we actually don't even really have to do any calculations here. We just have to know that 20% of 500 is going to be less than 30% of 500. But you could evaluate both of these functions for 500 and see what you get. So let's do that anyway, just to be extra sure. So I'm going to take out my calculator here. And I'm going to substitute X for $500. So if our sales is $500, then 0.2 times 500 is 100. So employee A would earn $100. Employee B is doing 0.3 or 30% times 500. 0.3 times 500 is 150. So employee B would earn $150. So employee B will earn more money. All right, number 3, which statement is true about the 2 functions shown below? So I look at my functions, I see I've got a graph and I've got a table. The graph is f of x and the table is g of x. And then I'm going to look at my answer choices and see like what are my answer choices talking about here so I know what to focus on. So I see we're talking about y-intercepts. We're talking about rate of change. We're talking about quadratic versus linear. Okay. So first thing I'm actually going to do here, I'm going to do the thing that I think will be the easiest first, because we've talked quite a bit about rate of change, or slope. It's another word for rate of change. So I'm going to go ahead and I'm going to figure out the slope for each of these, or I'm going to figure out the rate of change for each of these functions. So I'm going to do that with my graph, point here and a point here. I'm going up 2, and I'm going over 3. So up 2 over 3, I have a rate of change or slope of 2 over 3. Then I'm going to come over to my table. Going from -2 to 2 is an increase of 4. 2 to 6 is an increase of 4. 6 to 10 is an increase of 4. 10 to 14 is an increase of 4. And with my x's, I've got an increase of 1 each time. So I can actually see here, I just answered I figured out one of the other answer choices here isn't going to make sense because I just figured out that my table is showing me a linear function because it has a constant rate of change. So I know the graph is linear because it's a straight line. So that's definitely linear. But my table, it has the same rate of change throughout the whole table. And so it must also be a linear function. It's a linear function with a slope of 4 to 1, which is 4. So choice D definitely isn't going to work, right? G of x is not a quadratic function. It is a linear function. So even if you're not quite sure how to identify a quadratic function, you know how to identify a linear function, and this is one of them. So let's go back to our rate of change choice here. It says f of x has a higher rate of change. So f of x has a higher slope. Is it true that 2/3 is higher than 4? No, that is not true, right? 4 is higher than 2/3. So choice C also will not work. So that means we need to look into the y-intercepts for these two functions. So I'm going to go ahead and clear the screen here a little bit. So take a look at the graph first. What is the y-intercept of f of x? What is the y-intercept of the graph? Well, it's crossing the y-axis at -2. So the y-intercept is -2. Think about what this point is. This point is 0 on the x-axis and -2 on the y-axis. So it's the point 0, 2. So you want to notice that your x value here is 0. That will always be true for your y-intercept, right? Your y-intercept is always going to be lined up with 0 on the x-axis. So if we come over to the table, when we're looking for a y-intercept, you want to look for where the x value is 0. And I see that right here. I've got an input of 0, and I've got an output of -2. So it actually looks like these functions both have the same y-intercept. And so choice A is the true statement. All right, everybody. Well, thank you so much for joining me on this lesson today. Like I said, make sure that you go back and review the lessons from the last couple of weeks. Make sure you try the homework that has been posted on the Google Classroom, and make sure you get in touch with me if you have questions. I know that this material we've been working on, there's been a lot to learn, and I know it can be challenging, so I really appreciate you sticking with it. Take care.